Dear ladies and gentlemen, my name is Malikova and I would like to introduce you our work that is devoted to mixed-mode crack propagation in a semicircular disc under bending made of an environmental-friendly concrete. We worked on this topic together with my colleagues Miarka and Simonova, and our team works for Brno University of Technology and partially for Czech Academy of Sciences. Our presentation has got the following parts: introduction, aims of the work, experimental campaign description, details about the numerical model, explanation of the over-deterministic method used for calculation of the terms of the Williams expansion, maximum tangential stress criterion, then results and their discussion, suggestions made based on the conclusions, and few words about the ongoing and future work in this research field. Let's start with a short introduction. The thing is that it has been shown in the recent years that the classical linear elastic fracture mechanics concept that uses the stress intensity factor as the single controlling parameter for assessment of fracture behavior of specimens and structures with crack is not able to describe the fracture processes under specific conditions, especially when the fracture occurs in a more distant surroundings around the crack tip, which is typical, for instance, for quasi-brittle or elastic plastic materials. Then, a multi-parameter approach seems to be a good choice. It assumes approximation of crack tip fields by means of the Williams expansion, considering more initial terms of the power series. The main aim of the work is to investigate crack deflection under mixed mode loading and to assess the importance of the higher order terms of the Williams expansion for description of this behavior. Crack deflection angles were observed based on the experimental campaign as well as calculated numerically from generalized maximum tangential stress criterion. The following slide shows the information about the first part of the experimental campaign, measurement of basic fracture mechanical properties. It must be emphasized that the whole research has been performed on a novel material, particularly fine-grained composite based on the alkali-activated slag. Its main advantage in comparison to the common concrete is that it is environmental friendly, which is very important from the ecological point of view. To be able to use this material in praxis, its fracture mechanical behavior must be investigated and well known. You can see several details of the experimental setup, as well as values of Young's models, Poisson's ratio, fracture energy, effective fracture toughness, and specific fracture energy obtained on defined specimens. In this figure, you can see the concrete specimens and the laboratory testing. We follow with further tests, and it is 3-point bending test on a semicircular disc with an inclined crack. In the table, you can see the dimensions and other parameters of the specimen during testing. The values are valid for the results presented within this video. Nevertheless, the campaign is more extensive. Also, configurations with an eccentric crack and with not symmetrically located supports are being tested, and results evaluated in order to get a complex set of data for final conclusions. Here in this figure, the final failure of a semicircular disk is presented. Similarly, other tests are performed on specimens with an inclined crack and considering various values of other parameters. The following figure represents the numerical model of the semicircular disk with an inclined crack under 3-point bending. The model was created in ANSYS finite elements system. The task was solved as two-dimensional and the specimen was modeled via quadrilateral 8-node elements denoted as plane 183. A refined mesh considering the stress singularity at the crack tip was created by using kscon command, and plane stress conditions were prescribed in order to be able to compare the numerical results with data observed experimentally on the specimen's surface. This slide shows how the over-deterministic method is utilized for determination of the higher order terms of the Williams expansion. Displacements u and v and polar coordinates r and theta of a selected set of nodes around the crack tip are used as inputs for the basic relations derived for crack tip displacement vector components. Thus, a system of equations is created and its solution is a set of n and m coefficients an and bm respectively. When the coefficients of the higher order terms of the Williams expansion are known, an arbitrary stress tensor component around the crack tip can be approximated. And this is what is needed for application of the multi-parameter form of selected fracture criterion. In this work, the generalized MTS criterion was applied. It means that the direction where the tangential stress reached its maximum was searched. Note that whereas the classical MTS criterion is independent on any other parameter, its multi-parameter form depends on the radial distance where it is used. This distance is often called as the critical distance, and several recommendations on its estimation can be found in literature. For purposes of this research, the relation derived by Sich was applied. Finally, you can see the results of the correct deflection angles obtained. The first slide corresponds to short cracks with their relative length of 0.2. You can see dependencies of the initial King angle gamma on the crack inclination angle beta. Comparison between experimental results, dashed line, and results obtained via GMTS criterion considering various numbers of the initial terms of the Williams expansion, n and m was equal to 1, 2, 3, 5, and 10. Each plot is related to another critical radial distance, 0.1, 0.5, 1, and 1.5. Analogical results have been obtained for longer cracks with their relative length of 0.5. Based on the results presented in the previous two slides, following conclusions can be stated. When the generalized MTS criterion is applied at small distance from the crack tip, RC, it means critical distance, is equal to 0.1 or 0.5 millimeters, the effect of the higher order terms is small or negligible. For longer cracks, using the classical MTS criterion, considering only the first singular term, or what was orange curve in the plot, gives results very far from the experimental observation. There cannot be seen any unambiguous trend when more terms of the Williams expansion are considered for estimation of the initial crack propagation angle. But the results obtained via generalized MTS criterion are certainly closer to experimental results. When more general conclusions and final suggestions shall be made, it can be stated that the generalized MTS criterion should be recommended for quasi-brittle material with rougher microstructure, such as concrete, as the critical distance where the fracture criterion is applied corresponds to the region where the fracture occurs and to basic material microstructure dimensions. Also, the presence of the mixed mode conditions, configurations where the crack inclination angle is higher, beta is equal to 50 grads, and so on, is a good reason for using the multi-parameter fracture mechanics approach to get better accuracy of results obtained. Additionally, as a part of the ongoing and future research, configurations with an eccentric crack as well as with non-symmetrically located supports are being evaluated to get more complex set of results and to be able to state as general conclusions as possible. Also, the strain energy density criterion is going to be applied on the crack deflection angle analysis for comparison. I would like to acknowledge the financial support from the Czech Science Foundation and Faculty of Civil Engineering, Brno University of Technology. Thank you for your attention.